So 4 into 1.5, which is 6 volt. Let us not worry about the current right now. Current, okay, don't worry about the current. We are only solving for voltage. Okay, when the AH comes, I'll tell you. In the second case, it is 1s. 1s means 1 in series. We know number of cells connected in series decides the voltage. How many cells is connected in series? Only one cell. So 1 into 1.5. 1.5 is 1.5 volt. Then 8s 4p. 8s means 8 cells in series, so it is 8s. So 8 into 1.5, right? 8 into 1.5. So which is 12 volts. Here 15s. So 15s, that means 15 into 1.5. So number of cells in series decides the voltage. So you have to multiply number of cells in series into value of each cell. Okay, voltage of each cell, single cell. So it is 15 into 1.5 is 22.5. Right, again here 4s. So 4 into 1.5, 6. Okay, is it clear? Okay, parallel will calculate. Once we clear the number of cells or the voltage of the battery pack, then we can do H. So is it clear, everyone? How to find the battery pack voltage? How do you find battery pack voltage? You have to see number of cells connected in series. Take the number of cells connected in series, multiply by voltage of single cell. Okay, so number of cells connected in series into voltage of each cell. Voltage means nominal voltage. Normally we use only nominal voltage to calculate the battery pack. Okay, is it clear? Now let's say I want to make a 48 volt battery pack. Okay, 48 volt battery pack for two-wheelers. For two-wheelers. So normally you can say two-wheeler we use 48 volt system or 60 volt system. So assume I use a 48 volt system for a two-wheeler. How many cells of LFP? Okay, I'm going to use LFP of how many cells? I mean LFP cells shall be connected in series. In series. How many? It is 3 LFP. Okay, LFP, not 1.5 LFP. Whenever I say LFP, I never don't tell the voltage. You have to find it. Whenever I say LFP, you should understand. It's a what is the nominal voltage of LFP? It is 3.2. Upper cutoff is 0.65 and lower cutoff is 2.5. But don't use 3.65 or 2.5 to calculate the battery pack. You have to use only nominal to calculate the battery pack. Okay. Now we know one cell is 3.2. We wanted 48 volt. So 48 volt divided by 3.2. Okay, will give you number of cells. Number of cells in series. Number of cells to be connected in series. Okay, which is equal to 15s. 15s. Anyone, any doubt in calculating the battery pack voltage using the configuration? By knowing the total number of by knowing the total voltage to calculate the number of cells connected in series. Any doubt? Anything so far? Doubts? So now we'll go for AH. Yeah, parallel we'll see now AH. So how to find AH of the battery pack? Okay, so total AH, remember this formula, total AH is equal to number of parallel strings multiplied by AH of single cell. Okay, total AH of the battery pack is equal to number of parallel strings into AH of single cell. Now see that in the 1.5 volt cell, I am using 1.5 volt 3AH cell. Okay, 3AH. Okay, the AH of one cell is 3. Now tell me, for 4s 1p configuration, what will be the battery pack AH? How do you find total AH? Total AH is number of parallel strings. In 4s 1p, how many parallel strings are there? In 4s 1p, how many number of parallel strings are there? Only one. Multiplied by AH of one cell. Whichever the cell we have taken, 1.5 volt, 3 Ah. So Ah of the cell is 3. So 3 into 1 is 3 Ah. So this battery pack will be 6 volt, 3 Ah. Okay. And similarly, come to this one, 1s2p. 1s2p means how many parallel strings? 2 parallel strings. 2 into Ah. What is the Ah of cell? 3 Ah. So 2 into 3 is 6 Ah. Right. Now tell me for 8s4p. Tell me for 8s4p. What is for 8s4p? Yeah. For 8s4p, number of parallel strings is 4. Okay. Number of parallel strings is 4. So 4 into Ah of single cell. Okay. So 4 into Ah is 12 Ah. So it is 12 Ah. Okay. Okay. What is the doubt, Saravana Kumar? 48 volt divided by 15. What is the problem? 1 second.
इडली पे जब वो खाया जाता है ना, वो मसाला नहीं।
What you are saying? Saravana Kumar, 48 volt divided by 3.2 is 15, right?
उसका नाम कुछ थोड़ा गन पाउडर गन इसलिए कहते हैं कि तीखा होता है।
Point to where it came, you can see here LFP. LFP means what? LFP 3.2. LFP 3.2 is the nominal voltage of LFP cell. So we normally don't give 3.2. Okay, we will give only LFP. Pratham, yes, Pratham. This question will come, but this question will come in a very single line. Only one question is there, but I wanted to give you more options. So that is the reason I'm doing this big question. Okay, so I'll give you the question. Okay, don't worry, and you can note down the answer. Okay, so if you want, you can take down the question. All take down this question. Calculate battery pack voltage. Okay, battery pack voltage and Ah for battery pack configurations such as 4s1p, comma 1s2p,
मुझे कितना आ रहा है?
4s1p, comma 1s2p, 1s2p, comma 8s4p, comma 15s2p, comma 4s3p. Okay, using 1.5 volt 3 Ah cells. Yeah, LFP nominal voltage is 3.2 volt only, Kumar.
देखो।
Okay, tell me for 15s2p, Pratap. For 15s2p, what is the age? What is the age? 15s2p. Yeah, 6H, very good. 6H. Because we are using a 3H cell. Right? The question is using 1.5 volt 3H cell. So it is 2 into P, so 2P. So 2 into 3 is 6. For 4s3p, 9H, very good. H. Okay. So is it clear, everyone? How to find the voltage configuration is given. They don't ask you segments of machine. They'll ask you 15s4p using LFP. That's it. The LFP is 6H cell. That's it. But whenever it is LFP, you need to understand it's normally 3.2. They never tell you the normal. Anyone any doubt up to this? Finding the battery pack voltage and battery pack age. Any questions? Okay, I hope it is clear. So let me go back to the questions. Okay, please solve this. What is the total capacity of the battery pack when three identical battery cells, each with a capacity of 1 Ah, are connected in parallel? Total capacity of the battery pack when three identical cells with a capacity, each with a capacity of 1 Ah, are connected in parallel. Yeah, first you need to find how many cells are in, how many parallel strings are there. Please draw the circuit. Anyone? Draw the circuit. What the three cells are connected in parallel. Cells are connected in parallel. How do you draw the configuration? What will be the configuration? Yeah, it is 3s 1p. Okay, or it is 1s 3p. Is it 3s 1p or 1s 3p? So the question, if you read the question, three identical cells. Okay, three cells, each 1 Ah are connected in parallel. So three cells are connected in parallel. How does it look like? There are only three cells, and three cells are connected in parallel. That means it looks like this: one cell, two cell. So how many number parallel? How many NPs? Number of parallel string is. So how do you find total AH? So total AH is equal to number of parallel strings into AH of the cell. Correct? AH of the cell. So number of parallel string is 3. What is the AH of each cell? 1 AH. So 3 into 1 is 3. So it is going to be a 3 AH pattern. Correct? Do you agree? Any doubt? In parallel, AH will add. In series, voltage will add. Okay, remember, in parallel, AH will add. In series, voltage will add. Why do we don't use 3.65? No. See, 3.65 is the cutoff. Okay. So for example, if you make a 48 volt battery pack, okay, 48 volt battery pack, you are using 15 3.2 volt cell. Correct. And to make the battery pack, you have to calculate only the nominal. But when the cutoff comes only when charging. I mean, upper cutoff comes only when charging. Lower cutoff comes only when discharging. So that is the work of your charger. Let's say you have a charger. Your charger will monitor whether the battery will reach 3.65 into 8. Okay, so how many cells? 15 cells, right? So what is 3.65 into 15? So 3.65 into 15. And it is 54.75. Okay, so the charger will monitor whether the battery has reached 54.75 or not. Okay, so 75, then the charger will cut off the battery. Okay, so to make the battery pack, to get the configuration, we use nominal only. The cutoff value comes only when charging or discharging. Okay, that will be done. That will be a control point. Okay, basically that is a control cutoff. When you do charging, you need to cut off at 54.75. That doesn't come under a configuration. Those are cutoff points. So you choose battery. That is a stand. That's why we say what you call a 12 volt battery. You call 12 volt battery. It means the nominal only we call. But when the battery is charged, it will go up to 14.4. That 14.4, you need to cut off the battery. That work is taken care by the charger. That we don't want to worry about it. So when you choose your charger, you have to choose the charger which has 54 or 55 volt charger. For example, let me take you one small practical configuration. I use 8S 8S, let's say 2P, using 3.2 volt cell. 8S 2P using 3.2 volt cell. Tell me what will be the battery pack nominal voltage. Answer all the questions, don't worry. Okay, so we can discuss all the questions. I'll solve one by one and come to your point. Suppose if I miss your question, please again you put in the chat box. Okay, don't worry, I'll answer all the questions. So my question is that I'm going to use 8S 2P battery pack, sir. Okay, I'm using the LFP. Now tell me what will be the battery pack voltage. It's a 3.2 volt 6A cell. Okay, what will be the battery pack voltage? So battery pack voltage is decided by the number of cells in series. So you can definitely find 8 into 3.2. Correct. And parallel will be 2 into 6. So you can write simply as 25.6 volt is my battery pack and voltage, and AH will be 12A. So this is my battery pack configuration or battery pack rating. If I use 8S2P, if I build an 8S2P battery pack using 3.2 volt 6AH, I'll get 25.6 volt and 12AH battery pack. So now my question is that when the battery is full, 100% charge, what will be the battery pack voltage? Because I calculated 25.6 based on 3.2 only. I know each cell can be charged up to 3.65. So when I make the battery pack, when the battery pack is fully charged, what will be the battery pack higher cutoff voltage? How do you calculate that? Yeah, very good. 8 into 3.65. So if you calculate 8 into 3.65, you'll get 29.2. Correct? 29.2. So that means when the battery is fully charged, the battery pack voltage will reach to 29.2. So that means you have to choose a charger. When you choose a charger, can you choose a charger of 25 volt? Is it okay? If I choose a charger, can I choose a charger which has only 25 volt? Yes or no? No, because the 25 volt charger, assume this is the charger. Let me draw it separately. Assume this is your charger, 25 volt charger. And here my battery is initially 25.6. Battery, this is my battery pack. Okay, 25.6. Now whether this charger will charge the battery, yes or no? This is the charger. Charger is 25 volt. Battery pack right now is 25.6. I know that I can charge up to 29.2. No, I cannot charge it. Why? Because the current will not flow. Because current will flow from higher potential to lower potential. Correct? There is, if you look at here, you can see that current will flow from battery to charger. But that is not the desired current. We will have some protection. We'll have some diode protection, something like this, so that the battery pack will not discharge to charger. Let us not worry about that right now. But the question here is that whether the charger can charge the battery pack or not. Cannot charge. Why? Because the charger voltage is less. Battery pack is at the charge. Voltage to lower voltage. It gives potential difference. Tell me what will be my charger voltage? What should be my charger voltage? Should be 29.2 or 30, whatever it is. But 29.2 is fine. Why 29.2 is fine? Because when the battery also reaches 29.2, okay, 29.2, then whether the current flows from charger to battery, both side 29.2, whether the current flows from charger to battery. The charger is 29.2 and battery is 29.2. Now what is the benefit here? What is the benefit here? Because you know your battery pack needs 29.2, that is the maximum voltage it can charge. But after reaching 29.2, your battery should not receive any current. So if the charger is 29.2, if suppose you forget to cut off also, no current will flow. So suppose if I put 30 volt, assume, if I put a 30 volt charger, the charger will give current, but when the battery pack reaches 29.2, that time also charger is at higher potential than battery. So if you forget to cut off, there will be a current flowing from the charger to battery pack. But definitely we'll do cutoff. Okay, obviously there is a cutoff. There is no problem. The BMS will cut off it. But suppose I'm saying that. Suppose if we forget, or if the cutoff is not happening, 29.2 volt is still better charging voltage. Now I'll show you the charger in the market for 8S, and you can see what is the voltage of the charger. LFP 8S. Image is not clear. Okay, you can see here, are you able to see 29.2 output 29.20 volt? Okay, 29.20 volt. Okay. Even if you see in the text also, you can see 29.2 volt 5 amp. Here also you can see 29.2 volt 5 amp. Here also you can see 29.2 volt 5 amp. Okay, so this means that the charger output voltage, even the open circuit voltage of the charger, is nothing but the higher cutoff of your 8S configuration. Okay, so in this way you can even easily identify what is the charger you need to buy from the market for the configuration. Okay, is it clear, everyone? Any doubt? Any questions? If I miss any questions, you can put in the chat box. Let me read it. Anyone, any questions? If I miss any of your questions, please put in the chat box. If you use 25 volt charger, it will not charge. Yes, it will not charge. You have to tell why. It's very simple question, no? What is the doubt in that question? You just tell me. If suppose if you put a 25 volt charger for, let me, okay, look at it, charger. You are saying it is a 25 volt charger, and right now you have a battery. Currently, the battery voltage is 25.6. Okay, currently. Suppose if the battery is 20 volt, it may charge. Okay, 20 it will charge, 21 it will charge because there is a potential difference, current will flow. 22 it will charge, 23 it will charge, 24 it will charge. Then 25, when the voltage is 25, there is no current flows because both sides there is the potential difference is 0. But I said here the voltage is 25.6. Correct? There is no doubt the charger cannot give current to the battery. Is it correct? So my question is that what if suppose the 20 we started at 25.6, we're not told about 20, 21, 22, 23, 24 and all, right? So my question is that because whenever I make 3.2 volt cell 8 in series, I'll get 25.6. Now let's say I'm charging from 25.6. That's what my question is. So if you look at the battery is 25.6, your charger is 25. So it is the current will not flow. There is no doubt. Because the rule for the current will not look at whether this is a charger or this is a battery. Current doesn't know all these things. Current will flow only when there is a potential difference. Correct. Current will flow from higher potential to lower potential. That's it. Suppose if the battery voltage is 20 volt, then there is no doubt the charger will give current to the battery. It needs only potential difference. It never look at whether it is a battery or charger. It doesn't know all these things. Clear, Saranatma? So say 0 means it is minimum voltage, 2.2 volt. Ratna Prakash, it's correct. The charge, how do I select charger? I will select charger voltage. Charger voltage should be equal to or little greater than that of the higher cutoff voltage of the cell. That's it. No other confusion. The charger output voltage, okay, or charger maximum output voltage is equal to or is greater than or equal to. It can be great, little greater also, no worries. But minimum, it should be equal to the maximum higher cutoff voltage of the cell or the battery pack. So assume that I have a 15S 4P. Okay, 15S 4P. Now tell me, for this 15S 4P using 3.2 volt cell, okay, what will be my charger voltage? I wanted to make a battery pack of 15S 4P using 3.2 volt cell. What is my charger voltage? What charger should I buy from the market? Baba electrical auto current will flow. If it's that is not our question, that everyone knows, right? Current, that's what I'm saying. Current will never look at whether it is a battery or charger. If you give potential difference, current is going to flow. It is not only for battery and charger, anyway. But here the point, we are specifically talking about 8S series. Okay? We are not talking about general definition of current. General definition of current will flow anyway, everywhere, when there is a potential difference. If you give a 0 volt cell also, current is going to flow. But that is not the point over here. The point we are discussing for 8S cell. My question is that if 8S 3.2 volt cell is made of as a battery pack, the voltage will be 25.6. can we use 25 volt charger? That is the question. We're not talking about the generic definition of current that everyone knows. That's not the point here. Correct. Okay, so tell me for my question, Baba Electrical Automation, 15S4P, what is the charger voltage? The charger voltage. Don't tell if I sir 30 volt, if I buy 30 volt charger also current will flow. Current will flow, but you can charge up to 30 volt, right? Abdul, you can understand, right? So the point is not a school level question here. The question is, see, if you answer this question like this, for example, if I'm asking you 15S4P, okay, 15S4P, you will tell sir, we can buy 30 volt charger, current will flow. If you buy 10 volt charger also current will flow, but that means you cannot buy 10 volt charger one, 20 volt charger one, 30 volt charger one, 40 volt charger one, right? You'll buy only one charger. What is that charger voltage? That is the question. Don't misunderstand the question. Current will flow. That is a different part. Here we are talking about the charger. That's it. I cannot buy 10 or 20 chargers here, right? I can buy only one charger here. What is the charger voltage? So that I'll be able to charge the battery. Charge the battery. Whenever I say charge the battery, it means full charge. You cannot say, sir, I use a 30 volt charger to charge up to 30 volt. I use a 40 volt up to 40 volt. I use a 50 volt charger. No, that is not the question here. We can use only one charger here. What is that voltage value of the charger? How did you find? It is 15S4P configuration. 15S4P configuration, not 8S. 15S4P LFP. Right, 15S4P LFP. What is the charger voltage? That's give me one number. That's it. One voltage. Don't tell 30, 40, 50 and all. Only one voltage. I should be able to charge this battery. That's it. Okay, 48. Okay, somebody says 48. So if I use a 48 volt charger, what voltage I can charge? R Maurya, till what voltage I can charge the battery? If I use 48 volt charger, till what voltage I will be able to charge the battery? R Maurya. As you said, I buy a 48 volt charger. Till what voltage I will be able to charge the battery? Charge up to 48. Correct. Beyond that, you cannot charge. But tell me for a 15S, what is the higher cutoff? Till what voltage you can charge this 15S battery? I have a 15S series. Yeah, that is 15 into 3.65, right? 15 into 3.65. How much it is? 54.75. So that means I can charge this battery pack up to 54.75. So if I use a 48 volt charger, I cannot completely charge the battery. It is not possible at all, right? So that means if I can go up to 54.75 here, right, I should buy a battery charger greater than or equal to 54.75. Correct? Then only I'll be able to charge the battery. Is it clear? So, any doubt in this? What safety factor you want? The safety factor. Over voltage. See, 54.75, the BMS is getting cut off, right? See, this setting of cutoff you do at BMS level only. Correct. So that's why I have given you greater than or equal to. Suppose if you buy 54.75, there is no problem. Greater than or equal to 54.75, also no problem because your BMS is going to cut off the battery pack when it reaches 54.75. Clear? Kumar, why you are asking 3.65? Where we have taken? We are talking 3.65 from the beginning itself, right? You have to note down all these cutoff values. Cutoff is 3.65, lower cutoff is 2.5, or you can refer the data sheet. Normal is 3.2. Whenever the charger voltage is to be found, you need to think about the higher cutoff voltage. So the charger voltage should be equal to or little greater than the higher cutoff voltage of your configuration. That's it. Okay. Is it clear, Saranatma? Anyone, any doubt? See, it is not for separate batteries, sir. It is separate chemistry. Okay, lead acid is a different chemistry. Lithium ion is a different chemistry. LFP is a different chemistry. That's what we have seen in the beginning of the class. 12 volt, lead acid will have 14.4 higher cutoff. Lithium ion has 3.7 is a nominal, higher cutoff is 4.2. Lithium iron phosphate, LFP is 3.2 is nominal and 3.65 is cutoff, higher cutoff. The documents you can talk to FUND.PART-34. But these are the basic calculation, okay? The basic calculations which you can understand and develop practical calculation. I'm not doing any theoretical calculation here. All practical calculations only. Detailed document I don't have. You can talk to FUND.PART team. They'll be able to support. Okay. Anyone, any doubt up to this? Any questions? Any other questions? Anyone? Okay, so is it clear? Finding the charger voltage for any configuration? 3.65 is the upper cutoff voltage. Upper cutoff voltage for LFP. So we'll go to the next problem. So please solve this. If a battery has a capacity of 10 ampere hour, not 10 amps, 10 ampere hour, and it is being discharged at a current of 5 ampere. A battery has a capacity of 10 ampere hour, and it is discharged at a current of 5 ampere. Okay, 5 ampere in 1 hour. Okay, in 1 hour. Calculate the C, sorry, 5 amps, not in 1 hour, 5 amps. 5 amps, then calculate the C rate of the battery. Means that there is a battery whose capacity is 10 H. But this guy can discharge only 5 amps. Its maximum discharge current is 5 amps. Then what is its C rating? Yeah, very good. The answer is 0.5 C. If we say 2 C, it becomes 20 amperes. Okay. So 0.5 means 0.5 C means the cell will be able to give you, discharge you maximum of 5 ampere of current. So the answer is 0.5 C. Okay. Ashutosh, okay, Ashutosh, I'll check if any document available. Safety, we cannot get a single document with all the things. Okay, that is not possible. Only thing that we have to read the data sheets of cell and the data sheet of any battery pack, and then only we'll be able to decide. Because most of the companies, they don't give you any of their quality or design requirements outside as an open document. Only thing what we can get is we can get the cell details, cell data sheet, and we can also so this is the solution. You can note down the solution. So I is current, C is the capacity. Okay, C rate is I by C. So it is 5 by 10. So 5 amps divided by 10 Ah. So which is 0.5 C. Yeah, I'll give you, Ashutosh, don't worry. I'll try to, I'll maybe, let me show you some data sheets. Have you noted down all these problems? The solution is noted, right? If you want to know detail BMS, I have learned. Okay, that's what we are saying, that there's learned through data sheets, through testing, vigorous testing, different testing. Even if you give me 100 cells, I'll not blindly put 100 cells. and make a battery pack. We do some testing. So all these things are a lot of experimentations you have to do in order to find a best way to make a battery pack. So once you can go to Dali BMS. This is the place where I have learned initially about BMS, battery pack, all these steps. Test you have to see the standard IS standard. Okay, IS standard base nail penetration test, temperature thermal testing, so many testing that you can go to. Penetration test I will show you. You can study about nail test, battery design nail test department. This one, Department of Energy, and you can also ARA website. Okay, Automotive Research Authority of India, ARA. Go for AR. Also, technique there. And normally the standards are not open. Okay, we have to buy the standards. Okay, even for motor, for battery, and all there are different standards. We need to buy it. This website you can look on the how to make a battery pack. These things are available in this link. So you can enter for all these things, but this only for solving the problems in battery design. Okay. Anyone, any doubt up to this? Clear? We get 0.5. See, anyone? Any questions on this? Hitoshi, and this problem is done. So we have other problems also. So we'll continue in the next class. In the next class, we'll be solving the problem related to